So in this video, we're going to talk about vertical motion models. So we're going to be applying all our quadratics into some situations that are quadratic just because of the nature of them, and something you learn in physical science too. So your objective is that I can use vertical motion to solve a situation where an object is thrown or dropped, and I can use vertical motion to see the height of an object reaches a certain height. So on October 14, 2012, Felix Baumgartner did a free fall from 1,280 feet, which means he was on the edge of space because it's 24.211 miles up in the air. In doing so, he broke the speed of sound. This was a really big deal because he was the first person ever to, just by free falling, was able to break the speed of sound. I highly suggest in class you watched a video of it, but it's kind of very interesting thing that happened with him, and it's very fascinating that he was able to do this. Now, when he jumped out of there, he actually dropped. When you actually take an object, so let's say this is you, and you drop it. Now, when he first jumped out, he did not go as fast as the speed of sound, which he did break. You start off very slow, and then you speed up. So as you get lower, or as it drops, or you go faster. And that is because of gravity. So when you actually drop an object, say this is where you start, this is your height, and as time goes on, the object drops down and you're going to end up somewhere down here. Now the question is it a straight line, meaning you drop at a constant rate, or does your rate speed up? Well, because of gravity and because he was able to break the speed of sound, it speeds up. So it does not make a straight line. In fact, it makes... It starts off slow, and then it drips down, and you can see it makes that curve, and that curve, if you would see the other side of it, is a parabola. Therefore, it is quadratic. So what happens when you throw an object straight into the air? So now my person, instead of dropping the object, is throwing the object straight up, and then obviously what goes up must come down because of gravity, goes straight down. Well, in this situation, you start at a certain height. So say this is where the rock that he's throwing a certain height. Well, it would go up in the air, and then it would go down. So the same question, is it like this? Which is not, because of gravity. Again, as it goes down, it's going to get faster. So it's not a constant. It's not the same line. But what happens when it goes up, it hits a peak, and then it would go down. So again, you can see that quadratic shape, like so. So it makes a parabola. So now our third situation, you can say, is what happens when you throw an object straight towards the ground. So here's my person, and he's throwing it straight down as fast as he can. Well, you're going to have a height. Your object's going to start at a height, and it's not going to get any higher than that. And then you would think, before, when we dropped an object, it made this curve. But if I am going to throw an object, it's going to go down faster, so it's going to make something more like this. And then it's going to be like here. So it's actually just it's still a parabola, but it is a skinnier parabola because it goes down faster. All these situations uses the vertical motion model, and the vertical motion is represented by this equation. We can figure out how long it takes an object. So really, we're figuring out how long it will take an object to reach the ground. So in this equation, there are 4 variables that we can replace. T is time in seconds. S is your starting height. Now I know some of you who are in physical science, S sometimes stands for speed, but in this situation it's your starting height. So where did the object start at? H is your ending height. Where did we want the object to end at? Could have been the ground, could have been 5 feet off the ground, whatever we want to end at, that is H. And V is our velocity, which is our speed. Now velocity can either be positive or negative. And I should say velocity we measure in feet per second. If it is positive, that means we threw it up. If it's negative, we throw down. Throw up, throw down. So like this example here, when I'm throwing an object down, this would have a negative velocity. Downward velocity. Alright, so let's look at some examples. You're competing at Target Field event at a hot air balloon festival. You're throwing a marker down from the altitude of 200 feet towards the target. When the marker leaves your hand, the downward speed is 30 feet. How long will it take the marker to hit the target? So, let's remind us what our equation is. H equals negative 16 t squared plus vt plus s. So let's take a look at what this is. So you are up here in a little hot air balloon. So if you want to draw the hot air balloon, this is my attempt to draw my hot air balloon. And you are throwing a marker down. So it's going to look something like that. Now it started at 200 feet. So I'm going to put 200 feet. And then I want it to end. It says, how long would it take the marker to hit the target? Well, the target is located on the ground, so it ends at 0 feet. And then it goes at a downward speed of 30 feet per second. So since it's down, it's negative 30 feet per second. Well, I actually have all the variables I need here. Remember, we're solving for time, so we leave t in. V, negative 30 is my v. S, right here, S is my starting height, so S is 200, and H is 0. So I can plug in 0 equals negative 16 t squared, and then it's minus 30 t, and then my starting height was plus 200. Alright, so we have a quadratic and we need to solve. So the way we're going to do this, we're going to use our quadratic formula. So, reminder, it's negative b plus or minus square root b squared minus 4ac all over 2 times a. So plugging in, we have negative 30, so it's 30 plus or minus square root of 30 squared minus 4 times negative 16 times 200, all divided by 2 times negative 16. So simplifying this, we have 30 plus or minus, so we have 30 squared, which is 900, negative 4 times negative 16 times 200 gives me plus 264. Just multiply these three numbers together. All divided by negative 32. So we have 30. I can add those two together. Up here it's 1,164. So I can take plus or minus, I'm just going to take the square root of 1,164, and I get 34.1. Just the tenth is all we need. Alright, so just like before, we are going to have two answers, 30 plus 34.1 divided by negative 32, and 30 minus 34.1 divided by negative 32. Alright, so solving these both out, remember you add the top first, make sure you hit equals, and then divide. This is negative 2 seconds, almost exactly. And this is 0.12 seconds. Well, kind of thing, we're only going to have one answer. Because we're doing time, negative answers do not make sense. So 0.12, again that's seconds, is my answer. Alright, so now from the top of the 40-foot cliff, I'm going to drop a stone upwards, or actually it should be throw a stone. Throw a stone upwards at 20 feet per second into the water below. How long does it take the stone to hit the water? So here I am. I'm going to take a stone, throw it up, and drop down. So I start at 40 feet. I wanted to hit the water, so it ends at 0 feet. I'm throwing it upwards at 20 feet per second. So labeling each of my dimensions. And my 20 is my velocity. 40 is my starting height. 0 is my ending height. So I have 0 equals negative 16t squared plus 20t and plus 40, what I started at. So again, we're going to solve by using the quadratic formula. So negative 20 plus or minus square root 20 squared minus 4 times negative 16 times 40 all over 2 times negative 16. Simplifying this, we get negative 20 plus or minus the square root. Right here, this is 400, that's 20 squared. 4 times negative 16 times 40, it's plus 25, 60. So that's 2960, all divided by negative 32. So I'm going to take the square root of 2960 to get negative 20 plus or minus 54.4 divided by negative 32. Do my two answers. Negative 20, and I'm looking for whichever one is the biggest positive. Sometimes you may get two positive answers, that will happen. Whichever one's the biggest. Well, I can already tell this first one's going to turn out to be negative 32. What's that? 2. Going to be negative. Yep, negative 1.1 seconds. So nope, can't have negative time. 74. It'd be nice if we can go backwards in time with negative time, but we can't. But this one turns out to be positive, to be 2.3 seconds. So that is my answer. Only one answer at this, even though we have two. Alright, so this one you're standing on top of the Empire State Building, which is 1,250 feet tall, and you just drop a penny. So I'm here on top of the Empire State Building. If you want, you can draw the Empire State Building. Good geography lesson. The Empire State Building is in New York City. Alright, so I'm at 1,250 feet. Alright, and I wanted to hit the ground, which is 0. So how long will it take to hit the ground? I have no velocity. This is my starting height. This is my ending height. So I have 0 equals negative 16 t squared plus my velocity is 0 because it doesn't exist, plus 1,250. Alright, so I don't need this anymore. I can take this out. So I really only have 0 equals negative 16 t squared plus 1,250. Alright, so from here, since I don't have that b, I can just move this over. So I get negative 1,250 equals negative 16 t squared. Our goal is to isolate t squared. So opposite of multiplying is dividing. Take that difference, I get 78.125 equals t squared, square root. Time equals 8.8 seconds. How long my penny takes to reach the ground. Remember, there is plus or minus, but again, we're only looking at the positive answer for this situation. Alright, one last one. So we're actually going to figure out how long it actually Felix was in the air. Now you have to keep in mind a wind resistance and stuff like that. We're not considering. So this would be like if you fell and there was really no other air or air resistance around him. So in this situation, he is falling, but instead of ending at 0, he ends at 5,000 because at that point he hits the parachute. It'd be a very bad situation if he didn't release that parachute. But he did start at 2,800 feet, and his velocity is still 0 because he did not jump down, he just fell. Alright, so in this situation, we have 500 equals negative 16 t squared plus 0t. I'm not going to put it in there because we don't have it. And then plus 128,000. Alright, so since I just have t squared, we're going to isolate t squared. So I'm going to move over the constant term. Subtract 1,000 or 128,000. I get 123,000 negative equals negative 16 t squared divided by 16 is 7,687.5 t squared. Alright, so it took him 87.7 seconds of free fall before he hit his parachute. Minute and a half he fell. It's quite a long time. Alright, so kind of lesson takeaways. Thinking about here, we have vertical motion, so definitely need to know your formula. Plus VT plus S. Gotta know what each one stands for, which you can fill in from your other notes. Alright, for us to solve, you can either use the quadratic, but when you use the quadratic, you need to equal 0. But if there is no VT, or no velocity, you can use the square root method. Alright, that is it of part of your vertical motion.